Okay, and then the final example that we're going to look at is one where the rod is non-uniform. So non-uniform means that we can't assume that the centre of mass is going to be placed at the centre of the rod, and the word rod is basically something that has negligible thickness, and you don't have to worry about any bending in the system. So let's have a look what we got. A non-uniform rod AB of length 4 meters and mass 5 kilograms is in equilibrium in a horizontal position, resting on 2 supports at points C and D, where AC is 1 meter and AD is 2 meters. Okay, so let's get that going. So there's my rod. So if this is point A and it's a 4 meter rod, then I've got 1 there and 1 there. This one AC is 1 meter away, and the one at D is 2 meters away. And then I know that I've got a mass of 5G, and I don't know how far away that is, so that's going to be a distance of X meters, all from A. So let's just look at the information I'm given. It's a non-uniform rod. It's of length 4 meters. Okay, so I've drawn it awfully, but it doesn't matter. It's supported at C, which is a distance of 1 meter away. It's supported at D, which is a distance of 2 meters away, which is in the center of it. The magnitude of the reaction at C is half the magnitude of the reaction at D. So if the reaction at D is R, the reaction at C is a half R. Find the distance of the center of mass from A. So I want to find X. Okay, system is in equilibrium. So therefore, sum of the y forces equals 0, sum of the moments about A equals 0. So the sum of the forces, first of all, I've got RC, which is R over 2, minus 5G, plus R equals 0. Shall I tidy that up a little bit? Let's take the 5G over, and then I've got 1.5 R, which is 3R over 2, equals 5G. So 3R over 2 equals 5G. 3R equals 10G. R equals 10G over 3. So I know what the reaction force is, and from that I can work out the reaction force there, but the question's not asking for that. But that now allows me to use it in the second part of the work, which is to find X. So now we're going to take moments about A. So about A, I've got this force which is trying to turn it anti-clockwise. So I've got minus R over 2 times 1 plus the 5g force, which is trying to turn it clockwise, so that's positive, times x, plus r, which is trying to turn it anti-clockwise, so it's negative, times 2 equals 0. So I've got 1, 2, 3 forces, 1, 2, 3 parts to my moments equation. Okay, so let's tidy that up. If I take the r's over, so I've got 5gx equals 2r plus half r. So 5gx is 2.5, which is 5r over 2. And I know that r is 10g over 3. Hold on, I can cancel the 5, and I can take the g over, so I get r over 2g is x, and I know that r is 10g over 3. So the g's cancel, and the 2 divided into 10 5 times, so x is 5 over 3, so 1 2/3 meters. Center of mass of rod is 1 2/3 meters, or 5/3 meters from A. So A-level maths, A2 is the or mechanics, sorry. The mechanics is in forming your moments equation. The mechanics is informing your equilibrium equation, but the rest of it is just manipulating algebra. Okay, so those are the examples. All the questions that are in this little bundle of notes are past paper questions, so give them a go, see how you get on. The answers are on the back page.